Morning, everybody. Today I want to talk to you about how you can drive value through your automation assets and the techniques that we have used. This slide shows Dow Corning. I'm a heritage Dow Corning person, so a lot of this work was done through Dow Corning and now has been acquired by Dow Chemical. So what you'll see is the heritage Dow Corning work, but it's really talking about how we created a process that allows us to drive the value of automation within the company. So what I'm going to describe is a value-driven process. The process we used is a Six Sigma-based process. I'm a certified black belt, so I'm able to work through the process to make sure that as we go through it, we talk about the return on the net assets that we have invested that allows us to actually get the most and the best projects delivered on time and on budget. So the process really starts with that business value and understanding the business value. So in this case, we take the measures and metrics and the needs of our businesses. So we talk to them and say, okay, what's of most value to you? Is it safety? Is it productivity? Is it capacity? What are the things that you need out of your process to be successful? So let's face it, most companies, at least in the manufacturing space, in my case, the process industries, are in business to make something and sell it. So we have to understand what it is that's the most value to them for making and selling something. So the process starts with these discussions on what their needs are. And then in our organization, we had a standard set of metrics that we used, and we put those measures into place and said, okay, here's the measures that are going to measure what we want to do. And this is how we measure success. So what that led to is a quality functional deployment diagram that allows us to compare the needs and measures to determine which of the measures are best going to measure the needs that you have as a company or a business unit. So what that drove was, here is a weighted set of criteria, or this weighted set of critical measures that are associated with how you want to drive your assets, what you want to do with your processes. This could be automation, this could be how you run your process, it could be used for a lot of things. But in our case, we took the next step and said, we want to look at what is the scope of automation. So we said, what scope do you want to define in terms of how you want to drive this? In our case, we talked about process automation. So the process automation scope was defined for our organization, and then we talked about, with that, what are the functions through the process control experts that are defined as a part of that. So we said, here's the things that process automation does, and here's the people that talk about doing that through the control system experts within the scope we've defined. Then we rate those specific functions against those critical measures that we actually have that say, this is business performance, this is how automation might pertain to business performance. So this is the second quality functional deployment. We now have the highest rated business performance metrics, and now we talk about the highest rated functional requirements associated with automation that are going to deliver those business requirements. So this is driving business value, not driving risk mitigation, but I'll talk about that in a minute. So from those functional requirements, basically we were able to drive lots of different requirements. In our case, we have vendor requirements. We actually did a solution selection associated with this, where we actually use these requirements now to say, who is the best process automation supplier to meet our needs based on the criteria we've created on these functional requirements. It allows us to make a determination for us who could do that for us the best. And also drives these project requirements. Now we understand which functions we need to pay more attention to because they drive more business value for us. So we do a really good job on this set of functions, where some other functions you're probably just going to want to do an adequate job. And it also drives just generally the automation requirements. What level of automation do you need in your process that allows you to actually meet the business requirements without over allocating resources to drive different things that perhaps you do or don't need. So in the end, those requirements are driving our business value for how we're actually implementing automation within the company. So on top of this, so we created all these functions. There were 63 of them in our case. And we actually plotted them on a risk diagram. So this is actually the risk, and it's a typical two-dimensional risk diagram. What's the likelihood the risk occurs versus the impact of the risk? And for those functions that we defined, we now understand which risks we have to mitigate within those functions. That allows us now to overlay this risk capability on top of the functions we've defined. So it's risk mitigation combined with business value that drives what we ought to be doing. So the combination of those two things are really, really important in terms of picking the right projects for us to go forward with. So how did we use this? So again, as I just described, we talked about understanding the value of your automation. And then based on that, understanding the risk associated with all of the functions that you do in automation. And this really equates quite a bit to a life cycle stage of your assets. So I think we all have the stories of the 30-year-old, 20-year-old process automation assets that you have installed and the risk of those failing. All of that is part of this too. You go and you can study that and determine what the right life cycle stage and which projects should go first based on life cycle stage and risk, but layering business value on top of that. So again, we use this for vendor evaluation. And again, really what it came down to ultimately was a gap analysis that we used for project planning. And the gaps were in risk and the gaps were in value. So we could take the gap from where we're at to where we want to be, and we could pick the best solutions for our gaps. So let's look at the case study we had for Dow Performance Silicones, which the former Dow Corning. So we started out with 23 separate individual process automation teams throughout the world. So using this, they all operated autonomously, they all did their own thing. They chose their process primarily based on the risk associated with how old it was. And then there's no consistent way for them to actually do anything around what's the best thing to do, how to do programming in a consistent way, and how to use the vendor selection. Each project, it wasn't even each organization, picked its own vendor for that particular project. So using this technique, it was a Six Sigma focused project. We actually put that into process automation. We discussed it with our key business leaders within Dow Corning. We brought in the key automation engineers that could tell us the scope of automation and what functions were important in automation. And then we tied those two things together, and it was all sponsored by our business. In our case, our focus was on a functional part of Dow Corning called manufacturing and engineering. So we did it for the whole function, not for a business at a time, although you could apply it for a business at a time. We determined what was of value to the function. What were the functional requirements trying to drive in terms of the business value? Again, we've determined all the measures that we use to show that value through this function. And again, determine those functions, determine the greatest value functions by a weighting using a QFD, and then actually wrote very specific detailed functional requirements for each one of those requirements. So now we understand exactly what it is we're trying to deliver in terms of a functional requirement associated with that specific function. And again, layered on top of that, we did the risk analysis to basically assure that we could supply what we were told that we needed to supply. So as we thought about that, it's really that assurance of supply is risk mitigation, but there's not a lot of ROI because it hasn't failed yet. And then we layered the business value where we could actually calculate ROI much more effectively. So we look at this, I'll just give you some examples of how we've used it. First of all, in capital. So buying automation hardware and perhaps services. So it's the asset replacements or updates. Again, this is, in our case, historically how we did projects was, is it old? Is there great risk associated with it? Is that I/O card out of service now for the vendor that you bought it from? We got to replace that. It's a risk that we have that we don't want to realize, so we got to replace that and spend the money to replace that. Is it a new system and an old process? So now we're just going to tear out the whole system and put in a new system on the process. We had systems that the vendor didn't even exist anymore, so we actually couldn't get service. It wasn't even possible, so we actually ended up tearing out old systems and putting in new systems. And then, of course, when we expanded and grew, we had new processes and new systems. So we've used it for all of those capital-intensive projects to determine the best level of automation, the right automation, and the automation supplier that we wanted. So non-traditional projects. These are probably where we actually gain the most value out of our process. We now are looking at these existing assets and saying, how do we get value out of our existing assets in a more meaningful way? So these are rewrites of the automation capability within the existing assets. So non-capital projects, yes, you spend a little bit of money in expense doing this, but you're basically rewriting the program and rewriting the SOP associated with how that system works. So techniques using the ISA standards around 106 and 88 drove a lot of this, because we've created a technique that allows us to use those standards to actually drive a lot of business value through these rewrites. And almost always, I wouldn't say always, but almost always, the NPV, or return on net assets, for those projects was higher, because we didn't spend that initial capital. So when we talk about NPV, it's a life cycle discussion. It isn't about the investment cost, which is what the project economics will always drive you to. It's about life cycle costs for us. And this technique allows you to look at life cycle cost and value, not just initial project cost. So the other things that we look at were around people. So the people are now looking at all of these and seeing the value. The business understands the value. The efficiency we've gained around how we do this and how we actually program these systems. And then standardization even drives a lot more of that kind of stuff, including integration. So we've talked about digitalization pretty much all week so far. This standardization we had actually went through and helps us improve our level of integration from our systems, because it's connecting one thing to a bunch of other things as opposed to trying to connect everything to everything, which seems onerous in our perspective. So last year, Charlotte Dufresne, I just put a link in here, and the slides are contained in the reference to this, but last year, Charlotte Dufresne actually did a presentation that showed how we've executed some of these project evaluations. So I'm not going to go through the specific execution in that same level of detail. So let's look now and see what the results were from some of this. So using this technique that I just described, these quality functional deployment diagrams, here's some of the results that we've achieved. In one of our sites in a polymer business, it was a batch process. We put in a few more instruments, spent about $15,000, but we grew that process by $2 million. So we made $2 million more of saleable material than what we had before, and the NPV was $4.7 million. So that's $4.7 million of documented value that we've added through automation assets, primarily through rewriting how that process ran, and a little bit of investment in some more instrumentation. Next one is more of a rubber business for us. Again, a batch process. We took out some code where things were not operating as efficiently as they could, so we changed the automation in this. Basically, some expense dollars were spent there, but we took it through this process and analyzed it, and then it was an $80,000 annualized savings. And at another site where we were making intermediates in more continuous process, we spent no capital. We rewrote how the program worked for this continuous process to make it more sequence-based and continuous, and it gained us $2.2 million in sales. And my last example, in an emulsions process, again, a batch process. In this case, we actually replaced the control system with a modern-day control system, and we got a $4.6 million sales growth from actually implementing a different way of operating the process using the automation assets that we have. So the moral of the story is understand how automation in a measurable way affects your actual bottom line so that you can grow automation in a way that makes sense to the business, much more so than it makes sense of mitigating risk. You need to do both, but your executives and your corporation want to make money, and this is a way you can tie how we did projects to exactly how we're going to make money in the company. And capacity was a big thing for us, and these are all capacity improvement projects, basically. So with that, turn it back over to Dick.